Hello and welcome back to our Java API video. In this one, we just kind of want to explain how the Java API works. If you don't plan to use Java, you can watch the Python API video instead. But even if you don't plan to use it, I do recommend watching just to see how it works because Java is the native connector for GridDB. And so it does help if you just want to prototype something quickly. Java is usually the fastest way to go about it. So let's just get started here with the first file. It's called connection. And in this one, we just want to create a connection with our server. I'm being kind of a bad programmer, I guess. So I have a bunch of imports here that are not needed. I was just kind of lazy and copy and pasted a bunch throughout the different files. I'm probably using maybe 2 of these or something. So you can kind of ignore that, but you can kind of see how it works, right? So I use the grid store. I import the grid store, so I use it here in my code. The util properties is used to create the connection and stuff like that. So anyway, yeah, let's just go through this really quickly. So first and foremost, we're setting up our connection details here in the properties. This is assuming you're using a fixed list mode. With fixed list mode, you use notification member and you omit host and port. If you were using multicast or provider list, you would switch this one out with host, and then you would have another one underneath port, host, and port, and you would not have this one. And that's it. But basically, yeah, I hard-coded in my details because my GridDB instance shouldn't be changing. So yeah, you can feel free to hard-code your stuff. So these are all the default values for fixed list stuff. And to create our connection, basically you just have to get your grid store instance and just try a connection with GridDB. So at this point here, we're using the store variable, the grid store, to get container called device1. And at this point, this is when the Java program tries to call GridDB and see if it's there and see if the command makes sense. So you can run this, and if the container is null, it'll say connection failed. It's probably not a good error check because if it's null, it doesn't actually mean its connection fails, right? Because I could just not have a container in there called device1. But for the purposes of this, I mean, I know device1 is there because of the previous videos. And yeah. Another thing I would say here before I show this is, so you can see here my main function is throwing a GS exception. So this is the GridDB error. So ideally you'd want to put this in a try-catch, this program, and it'll catch the error if it exists, and that way you don't have to have this janky container equals null. But this is a very simple program where I'm just connecting to GridDB and showing the viewer, so it's okay, I guess. So I'll save this, and then yeah, to build, you know how to build, right? Connection.java. Cool. And then you do, and by the way, if you get some error about, you know, you don't have the class path set up or something, you need to, I'll just show, you need to have your class path, you need to have it pointing to your grid store jar. And if you do that and you get permission denied, you need to show your, you need to have your GridDB 5 pointing to your current user. So right now I'm under Israel. By default, it's GS admin and grid store, which it does need to be when you start and stop your GridDB server. But for running this, you need to change it, or you need to run as root, so you have permissions either way. I just temporarily changed it to owner to me because it wasn't working, but I think it's supposed to be fixed. Anyway, okay. Clear this. So it's already built. So now you just want to run it. and successfully connected, and then we close the container and we close the store. Cool. Really not much to it. Device one, as I said, we know exists already. Yeah, there's not much to it. So let's go through another one, then I'll pause and we'll go through the rest. Okay, next up here is create container. So we want to create a container this time. This time I did add some more imports on top of the previous ones I had. I'm just moving this for alphabetical order sake. I also added a date library from Java itself. So you'll probably guess, seeing these two things here, that this is going to be a time series container we're going to create. I guess I could rename this to create time series, but maybe I'll worry about that later. Okay, so in Java, to create your schema of your project, you actually create a class. And the schema is literally just all the, sorry, I'm not sure what the actual word is in Java, but basically all of these correspond to a column, and you put the type and the column name. So when we want to put data into this, we just create a new variable of this class, and you can input data like one by one per column. It's actually really easy, and I think it's easier than using the other, compared to Python and the other connectors. So here we're making a class called device, and the first row is, of course, a RowKey. Sorry, I didn't mean that. The first row is a time series time series. So it's type date. So when you're using Java, type date is a time series timestamp type. And you do have to write RowKey here. If you don't, it won't be the RowKey. I think it might fail. We can actually try that and see. I'm actually not too sure, but let's see. So once we establish what our schema is going to be, we need to create our connection again with GridDB. So this is going to be in basically all the top of every main function we have in all of our different code examples. Yeah, it's obviously not the best practice, but demo purposes. So basically, it's it's even shorter than the previous one. I guess maybe equally short. So once we establish this is our schema, if we want to create our container, we use the store again, the grid store. And we use the API called put time series, and we're calling it here device 13. And see here, you can see the return type is going to be of time series, which is this. So it's time series container, and it's type of device. We put in here, and here you also put the device type. So yeah, this will create the container called device 13 in our GridDB server, and we'll print out a simple successfully created. And we're not really error checking here. As I said, we should do a try catch, but it's very simple stuff. There will be no error. Okay, so let's save this. I don't know what I changed, maybe just spaces and stuff. Create container. Okay, and then let's actually go to our shell. I have the shell open here. I'm going to drop container device 13. I don't know if it exists or not, but I guess it doesn't matter. It won't give me an error either way. Okay, now let's try to run this. Successfully created device 13. Okay, so actually this should be lowercase. This is not uppercase. I'll save that. Okay, let's create again to get rid of that. Okay, so it won't give you an error. Even if the device already exists, it won't give you an error. So it'll just say, okay, it's already there. Okay, now let's do show container device 13. And we can see here timestamp, RowKey, and sorry, let me make this bigger. We can see here it's type time series, and it has a name and all that stuff. So cool. All right, let's really quickly just remove the RowKey here. Let's see how it handles that, because in the other connectors like Python and Node.js, you have to explicitly say RowKey equals true. And if I remove the RowKey from here, I wonder if it'll work. So as we saw, it works here. So now my assumption is, because it's a time series container and the first row must be a timestamp and it must have the RowKey. My assumption is it'll show the exact same thing, but we won't know until we try it, right? So let's drop this. Show container, okay, not there. Whoops, let's go to our other terminal and let's recompile and rerun. Oh, okay, so that makes way more sense actually. So illegal schema, right? So it's telling me this schema does not make sense. There's no RowKey. It needs to be required for time series. Okay. Well, that's even better than I expected. So even without catching the error, the compiler found it for us. So let's create that again. Let's build that again. Let's go back here. Let's make sure everything's good before we move on to the next examples. And we are good. Okay. Let's just go into insert and then I'll take a break and continue with the rest. Okay. All right, so insert data is what it sounds like. We are going to, why is this spaced all ugly? I don't know why is this going to 8. It's really annoying. Okay, sorry. So insert data is what it sounds like. We want to insert data into our newly created device 13. And here again, we're using date and time series because obviously, as we know, the device 13 that we have created for this example is of time series type. So we once again have our device class here. There's a reason for that because as we go through and want to insert our data, sorry, this spacing is kind of grossing me out. Let me fix this. Sorry, I had like 8 spaces for some reason. Okay, so let's start from the beginning. We're doing the same thing as before. We have our connection details. And then we're, so here we're putting time series again, which may seem odd because the device 13 already exists. You don't have to do it this way. You can also do like a get, but in GridDB it works the same way. So me saying, hey, put this container in here, it'll still return that container time series device to this variable. So it works the same. In another example, I will show the other way to get containers without using put. But basically it's the same. So if you're confused why we're putting again, it's just an easier way to get the container. Okay. So this is why using Java I think is a little better because here now we're creating a new class. We're creating a new variable called device, and it's a device type, which is this type we made here, this class. And now if we want to put data into our device 13, we basically just need to populate each of these objects, each of these columns basically. So here I just made up some values. So device.co is going to equal this, blah blah blah. You obviously just have to make sure that it matches the data type. So if you see here, I have every column set except for the most important one, the date. You notice there's no, like normally I would have to do device.ts equals blah blah blah. But because this is the Java API, what TS is going to do actually is when we go into place our device into our container, device 13, the grid store is going to put the time series element for us because it sees it's a time series container, and that first column, device.ts, GridDB will automatically insert the current timestamp into our device 13, which is pretty cool. So you can obviously set it if you want to something explicit, but it'll just assume like, hey, whatever code you're running, you're probably running it for code that needs to be run. That stuff that's happening right now. So I think it's nice because sometimes you just want to do a prototype and the time object sometimes is kind of tricky, especially if you're jumping around languages for whatever reason, which I guess I tend to do. Okay, anyway, so let's build this. And let's try to run it. So first, let's just make sure there's no data in here. So SQL select device 13. Actually, you don't have to write SQL in here. You can just do select from device 13. And sorry, that came out ugly. Okay, 0 results. All right, now let's run insert data. Successfully placed a row of data into device 13. Okay, I need to get rid of this capital D. All right, let's go back to query. Now we get one result. And now we get the current time, which even though I didn't specify, you can see that it's been placed here. And all the other the other data that I made up is also here. You can compare. Okay, cool. So far, pretty easy. So let's take a break, then I'll come back and do the rest. All right, so now we're going to continue on with the read data. Yeah, read data is exactly what it sounds like. We're going to be querying our database. So in this case, let's just go through it actually. So, okay, so first we're going to do the usual. We're going to get our grid store instance stored in a variable called store. And here you're going to see something a little different. So instead of grabbing our container by using the put container, last time I used, for example, the time series type, and I grabbed the container that way. This time I am using the grid store, and I'm using the get container. And here you just put in the container name, and then it returns a container type. And yeah, that's simple. So now our container contains our container, which sounds funny. And then here I'm doing if container is null, print out, hey, it's null, then close the container. Yeah. And then we're going to set auto commit to false. You have to manually do this part for consistency issues with GridDB on Java. So that's what we're doing. If you don't do this, it does give you an error. So you do have to do this. Actually, maybe not this one because it's it's just a read-only file. But down the line, it'll come up when we're updating data and stuff. So actually, let's try to remove this for now, just to see if I'm right. I'm pretty sure I am. And then I don't need this. I'll just delete this. Okay, so now we're going to actually run our query. So we use the container we got earlier, and we do call the API query. And now we write our TQL query in here. TQL is the GridDB query language, which I'm sure you've heard me say many times. So here we're just going to do a select all. Obviously, there's only one row of data in here. It's not going to be that exciting to see. So here we do select all, and then we get it goes into our variable query of type query. And then we actually fetch that. So we do a fetch true, and it gives us a row set. So I've explained before, but it gives you a row set because it obviously will give you one row or more if the query is successful. So you can't just give you one row of data because it wouldn't make sense. It gives you an entire set of rows, and then you have this this thing called row has next. So it'll have like a cursor going through each row that it has returned in it, and then if it has next, it runs a while loop until you basically iterate through all the rows, and then that's it. So here we're going to use row has next, and when the row has next, we'll just make a new variable called the row of type row, and we cast it into row, and we just make that next row into row, and then we print it out, and that's it. We only have one data point, so it's not really going to be that exciting, but this kind of just to show you how you can run a query on using Java. Okay, read data, compile, and then this time I don't have any messages because it should print out our values. I didn't do all the rows. You can. It's not really that important. Oh yeah, so here you go. See, auto commit mode must be turned off for a lock operation. So you must. Oh, I think this is why. Okay, yeah. Anyway, okay. Let's just change this. So I guess, yeah. Okay. Let's just try again. Okay, there you go. So obviously our row has more data than this. I just pulled the first couple. So I got the timestamp, the carbon monoxide, and the whatever it is, the humidity. So there we go. All right. Now let's try to update our data. Here we go. Here we're making a new class actually, or sorry, a new container. Only reason why I did this was because I wanted to show you using the collection container. So now notice I don't have the time series up here. I do still have the date though, because I do have a row in here that's timestamp, but it's not the row key that's timestamp. Okay. So same old, same old. And then this time we're doing the put again, but this time it's going to be the put collection instead of the put time series. And we're going to get back a collection container, and it's of type device master. And we're going to make it called device master 13. And then of course here there's also device master class. We also have to set auto commit to false here again. So right after we call this variable called call, I guess, you'd make it auto commit false, and then we do the same thing we did before. I'm just inserting data in here so that I can show you an update of it. Actually, wait, let me prove a point here first. So let's get rid of this RowKey thing here. Save this. So as I explained in other languages, in the other connectors, you would put the RowKey inside the column info variable, but here there's no column info, right? You're just creating a class. So let's omit the RowKey and see what happens. Okay, so here we're making a new object called device master of type device master, and we're going to set it these rows of whatever we want. I'm not doing the time series. I want to see if GridDB is going to insert that for me. So here, last inspection is a date. So let's see if GridDB will insert in for that, or is that like a specific time series container operation thing? Okay. So I'm creating this. I'm filling in every column except for the time series, and then I'm going to put that into my GridDB, and I'm going to commit that. And then I want to change this column from working to failure, and then I'm going to put that again, and then I'm going to commit it again. Okay. So one thing. So this is called update data, right? So the way update works is you basically just put data back into GridDB, and if that row key already exists, it'll just update that same row key, because you can't have the same row key. That's the whole point of having a row key. So if device 1 is there and you send it again, but you change one of the columns, it'll update that column, right? So once I send device 1 over, it's working, and then I change it within the same line of code. So we expect it to be failure, right? So let's make this. Okay, let's see what the error is. Schema changed. Oh, okay. I need to drop container device master 13. Okay, so that should not be an error that comes up. It's just saying that because that already exists. Okay, so let's run it again. Okay. So now if we do show container device master 13, you see here, everything is good, everything works, collection type, no row key though, right? So let's do select from device master 13. And you see here we have 2 results, and there's 2 device 1s, and it's a working and failure. So actually in this example, I didn't update anything. I didn't update device 1. All I did was create 2 rows, one with object, this object, and the working as the information, and then again that same object, but I changed the failure. So this is actually not what we want, right? We want to update information from working into failure, and so you do that by having a row key set up. So it should generally be the first column, and since this is a collection container, it can be of any type, but in this case, of course, a string. And one last thing to say before I run this again is, you can see here device 1. You can see here that the timestamp was not placed for us by the program. So it only works on time series containers. So for now, it's going to be a null, which I'm fine with because, you know, it's a demo. But that's something to be aware of too. So if it's something like this, you would have to explicitly put in a timestamp using, you know, the Java date stuff. Okay. Let's try to build this again with the row key in there. Actually, no, I can't because it's going to give me an error. So let's drop container again. Okay, and then let's recompile and rerun. And now we should expect one row. And now we get, it's been updated. So the code runs through, it creates a row of this with the working, and then it commits, and then the device says, actually, it's a failure. We put it again. Instead of giving us 2 rows as before, we update that exact same row with a failure. And if we do a show container, we'll see that there's an index of type equipment and the row key is index. So the row key is equipment. So the index is created automatically for us of type tree because it's the row key. And yeah, we're good. All right, let's do delete, and then I'll go on a break, and then we'll do the last one. Okay. All right, so last one before the break, I guess, is I'm just going to do a simple delete. So it's not that different from update. You call the delete API call, and you put in the row key, the row key, and it'll delete that row. That's it. It's very simple. So before we do all that, though, we need to get the container. So we're going to get the container that we want to target. We're going to target device master 13, which is the one we just did. I'm mostly doing this using this container because if I wanted to delete a row from the other device 13, the other one, I'd have to give it a timestamp. And I just don't feel like doing that. It's easier to just give it a nice string like this, device 1. Call it being lazy if you want. So let's do this. So basically here, I'm doing everything the same as before, set auto commit to false, and then I'm going to do container remove, and I give it the row key name, which we already know is device 1. You commit that, close the store. I'm not even going to print anything. We can use the shell for that, not a big deal. So let's try this. Okay, no errors, no anything. Let's go back here, select, and there's no more rows because I deleted it. All right, cool. Okay, let's take a break, then I go to the last one. All right, so the last thing we want to go over is the aggregation calculation. There are actually quite a few of those. Here you can see in the Java API. You can do it in the other languages too, but here in the Java API, you can see some of the aggregation. So this is the aggregation type, and you can see what is here. So you can see average, count, maximum, minimum, standard deviation, total variance, weighted average. For this example, I'm just going to do the average, but you can see if you go through the docs, you can try the other stuff too. It's not that complicated. Okay, let's go back. So yeah, to do that, I also added the aggregation result, which is the return type. When you use aggregation, it's the return type. Let's see, where do I find the aggregation result? This is the return type. Stores the result sorry, I can't speak. Stores the result of an aggregation operation, right? Okay, and then we're also, of course, calling aggregation. Okay, let's go through this. So once again, here I have the class that we're dealing with, device. We're going to be using the time series container this time. Normally I don't actually bother with putting the class everywhere, but in this case it does make it a bit easier to manipulate what I'm trying to show you. Another thing too is I actually added another property here, consistency to eventual. Since this is only a read-only operation, we can get away with setting the consistency to eventual. You don't have to keep it strict like it normally is. If you're writing to the database, if it's a multi-node cluster or something, you want to keep the consistency, or you have to keep the consistency good. Here we're just reading, so it's okay. All right, going through this. So I'm getting the container, get time series device 1, it's of type device here, time series container, and then we're going to run our query. So our query here is nothing fancy. It looks fancy, maybe. But basically, I'm just grabbing the row the row immediately after this arbitrary time I picked. So I just picked the entirety of this data set goes from like July 10th through July 20th or something like that. So I just picked one day in there. And this time next will just pick the very next time after this one that I selected here. So query is going to have that. Okay, and then it's basically just going to be one result. So while RS says next, so basically here I put next device. It shouldn't really be next device, it should be next row. Next row after this query, but it's okay. I don't feel like changing all the stuff. Okay. And then next is going to be next device's timestamp. So whatever timestamp is returned here, that's going to be next. And then it says, all right, obtain the data around 10 minutes before. So start time is going to be next minus 10 time unit minutes. So minus 10 minutes. And then start point is going to be TS get. So TS is our device 1. We're going to get from start. Okay. So start we know is 10 minutes before this. So it's going to be July 12th, whatever time, right? And then we're going to calculate the average of the data for 20 minutes around the point. So 20 minutes around the point means we're going to do 10 minutes before, which is start, and then we're going to make the end 20 minutes after next, right? So that gives us a 20-minute time period. So now we're going to get the average. So we're going to run TS aggregate, start time, end time. So 10 minutes before, 10 minutes after. We're going to target the temp, how do you say, column, which is temperature, and the device, IoT device. Yeah, you can see, I guess I also have it here. Yeah, temp is the temperature. And we're going to run the average. So we could also do, let me scroll back up here. We could also do, you know, variance or weighted average or what have you, count, doesn't matter. Okay, so we're going to store that result in aggregation result, and then we're just going to print out the timestamp from next, and then we're going to do the start point temp, next device temp, and then we're going to get the average, or we're going to have the average here, and we're going to do get double, and that's it. Okay. Okay, let's make this a little bigger. Clear this. All right, so basically the time that I was talking about the whole time, the time right after this one was 2027-13, 2 seconds and 641 milliseconds in. The start, when we get the start, which is 10 minutes before this, the temperature was 21.5. The next, which is 10 minutes after, I guess that sensor, the temperature went up 21.6. And then the average between that is just 21.6950. Okay. Not really that interesting, right? Because how could it be? Let's change this to hour. Let's see. I haven't tried this. It should work. There's really no reason it shouldn't work. Let's try this. All right. So this one is still the same, right? Because we're still using the same data point of next according to this original query. But now we are going 10 hours after and 10 hours before. So it's a 20-hour time window. And now we can see our averages is much more big, but still not big. So let's try a day, I guess. See how much variance we can get, because the temps don't change that much, I guess. Okay, and if you do between 2 day time window, doesn't change that much, 21.906. Okay, well, I hope you get the point. So basically the aggregation will give you start with a start time and end time, the column you're targeting, and you choose what you're targeting, and you can do some really cool stuff with time series data. All right, that's all. I hope you enjoyed. Have a good one. Thank you.